All right. Sorry if I didn't have the mic turned on earlier. I just told the story about Frederick Gauss, and then we talked about Helen Keller. So we're gonna do partial sum of arithmetic series. Sum of n terms is equal to n, the number of terms, divided by 2. So we said that we would take, instead of 100, we would take 50 sets of them, right? From the example we just did. And you simply just took the first term plus the last term. That worked out quite nicely, didn't it? So look at what we have here. It says you have an arithmetic series. You start with 1. So 1 plus 3 times 1 will be 4. You plug in 2 and you get 7. It's going to go up by 3 every time. And the very last term, it says we plug in 20. And so when you plug in 20, you get 61. So we'd like to add up all of those numbers. And it sounds like it would be really tough to add each one up one by one. But the fact is, all we have to do is the sum of the first 20 terms is equal to the number of terms, which is 20, divided by 2 would be 10, right? And then we add the first term and the last term. So the first term is 4, the last term is 61. So we're not going to have 20 sets of numbers. We're going to have how many? 10, and they all add to 10 times 65, and you get 650. How do you like that? Not too bad at all. Why don't you try B on your own? Go. All right, here we go. So you plug in 1, and you get 96, and then we get 92, and we get 88, and we get so on and so forth, all the way down to we've got 40 here. So the sum of 15 terms is going to equal 15 divided by 2, and then we're going to multiply 96 plus 40 together. And I just worked that through, turn on my calculator, and I got 15 times 96 plus 40 divided by 2, and I get 1020. Is everybody good with that? Great, good work. Flip it over. What's different about letter C? We don't have no symbols or anything. Very good, thank you. What else? We don't know how many terms. The sum of n terms is equal to, we take our first term, or I'm sorry, we take the number of terms times negative 8 plus 58, and we divide it by 2. So once we find n, we'd be set, right? So how we can find n? Magic? Nope, good try. No magic. Good idea. Not quite. Kind of wondering what term number 58 is, right? So 58 is equal to some, or negative 8 plus the difference. What's the difference here? 3 times n minus 1. Would that formula from yesterday help us? Sure would. So we get 66 is equal to 3 times n minus 1. Or 22 equals n minus 1. Or n is 23. So I plug in 23. Negative 8 plus 58 is 50 divided by 2. I got 23 times 25, which is 575. You like this? What's 25 times 25? 25 squared. You guys all know your perfect squares, right? 625. So you're going to subtract off 2 25s or 50. So 625 minus 50 is 575. Try next one on your own. Go. Listen them up. All right, here we go. Let's see what you got. I have the sum of the first n terms is equal to n times 9 plus 882 divided by 2. What did you figure out n was? 98. So you got 98 times 9 plus 882 divided by 2. And what did you get? 43,659. Me today? Oh, I've been preparing. Oh, yeah. Yeah. Yeah, I am. But I took lots of drugs today. So I'm. No, I thought about it, but no, I took some ibuprofen. I've got some more I can use. So my back pain is a little bit gone. Like last night I went home and definitely felt bad enough to not come to school today. But I was like, you know what? Get a good night's sleep. Take some ibuprofen. Take some Sudafed, and uh, and get some Mountain Dew in you. A little bit of orange juice. Yeah. Okay. So I'm ready to go. Teach some math. Get excited. Yeah. I have this feeling that when I get to the end of school and track, that my body will then go into like shutdown mode, and I'll be like sick for like 3 weeks. But hey, you know what? Live life now, right? Exactly. Sum of n terms. Suppose you have geometric series. That's different. We take a sub 1 and we multiply it by 1 minus r to the nth power, and then we divide it by 1 minus r. So in this situation, stop your whining, Maya. In this situation, yeah, whatever. So in this situation, you don't need to know the a sub n term. You just need to know the a sub 1 term, and then r. You also need to know the number of terms. So watch how this plays out. I plug in 1. 1/2 raised to the 0 power is 1 plus. Then I plug in 2. 2 minus 1 is 1. 1/2 to the first power is 1/2. And then I plug in 3. 3 minus 1 is 2, and 1/2 squared is 1/4. So do you see what the ratio is? Do you see what you're multiplying by every time? What? A half. And it's sitting right there, isn't it? Yeah. So once we figure out the first term, which is the number in front, we're good to go from there on. So we're gonna add these up. The sum of how many terms will there be? 9 equals, what's the first term? 1 times 1 minus, what's r? It's a half. Raised to what power? 9. Divided by 1 minus 1/2. Okay, there we go. Let's work that guy through. Looks really confusing, really not that bad at all. Sum of 9 terms is equal to, well, that looks like a Q there. Sum of 9 terms is equal to, so what's 1 minus a half? A half. Add, or what is dividing by a half the same as? Multiplying by 2. So I've got 1 minus a half then to the 9th power. So that's really what I'm calculating. I'm going to plug that in my calculator and turn it on. I go 2 parentheses 1 minus 1/2 raised to the 9th power. And I get that thing. You want it as a fraction? Math, convert to fraction. 511 over 256. Krista, what do you think about that number? She's kind of quiet today, Rachel. What are we going to do to wake her up? Wow. Oh, whoa. Okay. Let's try the next one. What's the first term? Should be able to just look at it and see the first term. 6. What's the ratio? 2/3. So if you multiply 6 by 2/3, what do you get? So we're going to find this sum. The sum of how many terms? 6 is equal to 6 times divided by 1 minus 2/3. What's 1 minus 2/3? 1/3. What's 6 divided by a third? 18. So we've got 18 times 1 minus 2/3 of the 6th power. So 18 times 1 minus 2/3 raised to the 6th power. Give us the fraction. Math converts fraction. 1330 over 81. Nope. I know, because 81 would be divisible by 3, right? 9. So, and if you look here, 1 plus 3 is 4, plus 3 is 7. So it adds to 7. 7 is not divisible by 3 or 9. Do you know that trick? Oh. Okay, here's another trick. If it's an even number, it's divisible by 2. Did you know that trick? Here's another trick for you. Here's another trick for you. If it ends in a 0 or a 5, then it's divisible by 5. If it ends in a 0, it's divisible by 10. There's not that many. That was a funny one. All right. Letter C. This one's tough. I have the sum of n terms. This time, we don't know what n is. We don't know how many terms there are. But I do know that I'm not multiplying by 10, but rather by 1/2, right? So I have 10 times 1 minus 1/2 raised to the n power. Divided by what? What is 1 minus 1/2? What's 10 divided by 1/2? 20. So I have 20. Shoot, if only I knew n. We do. We have this formula. It goes like this. A sub n is equal to a sub 1 times r to the n minus 1. When did we ever use that? Yeah, geometric sequences yesterday. Good job, Parth. Glad somebody pays attention in here. Previous page. Very good. So if we know that a sub n is equal to a sub 1 times r to the n minus 1, can we use that information to figure out how many terms there are? Well, what's the last term? So at 5/32 is equal to, what's a sub 1? 10 times what's r to the n minus 1. I got to find n. What do we do? Divide by 10. And when you divide by 10, you get 1 over 64 is equal to 1/2 raised to the n minus 1. So how do I get rid of the 1/2? What'd you say there, Noah? No, what'd you say? Logarithms, yeah, baby. Nice. Nice job. How do we get rid of the 1/2? We take the log base 1/2. All right. So look at the right hand side. Log base 1/2 of 1/2 cancels out. What are you left with? N minus 1. That was easy. Look at the left side. Log base 1/2 of 1/64. How do we plug that into our calculator? Do you remember that? Log of 1/64 divided by log of 1/2. And we get 6. So what is n? 7. N is 7. So I go back up to my problem, and I say n is 7. I'm going to go ahead and plug that 7 in now. No. 20 times 1 minus 1/2 raised to the 7th power, and I get 635 over 32. Cool. I did the more challenging one. I left the easier one for you guys. You guys try letter D on your own. Ready? Go. Oh, that's a good point. All right, this one right here. We've got the sum. I've got the 3 times 1 minus 2 to the nth. And I got 1 minus 2 on the bottom because 1 minus 2 is -1. That ends up being -3. So I got -3 times 1 minus 2 to the nth. Just got to figure out what n is. So I said 384 equal to 3 times 2 to the n minus 1. Divide by 3, I get 128. And then how do I get rid of the 2? Log base 2. And what do you get then? What is log base 2 of 128? 7. So I got 7 is equal to n minus 1. So what is n? Law of sevens. So n is 8. So I put the 8 right there, and now I calculate it. -3 times 1 minus 2 raised to the 8th power, and I get 765. Good job. I told you last page would be easy, right? And it is. It is super easy. Suppose we were to add up an infinite number of terms. We weren't going to stop. We had an infinite number of geometric terms. The formula is super easy. We simply take the first term, a sub 1, and we divide it by 1 minus the ratio. Look at this one here. You plug in 1. What's 1/2? 1/2 to the 0 is 1. Then I plug in 2. 1/2 to the 1 is. Then I plug in 3. 1/2 squared is. Everybody agree that's what we get? Now here's the interesting thing. When you add these up, 1 plus 1/2 is 1 1/2. Plus 1/4 is 1 3/4. Plus 1/8 is 1 7/8. Plus 1/16 is 1 15/16. What is it getting really close to? 2. Right? Yeah, 1 plus 1. So the second part, the fraction is getting really close to 1, right? Plus the 1, we got 2. So watch what happens. We take the first term, so the sum is equal to the first term, which is 1, divided by 1 minus, what's the ratio? 1/2. What's 1 minus 1/2? That's it. We should be able to look at this and know what the first term is. What's the first term? We should be able to look at this and determine what r is. What's r? 6 divided by 1/3, which is 18. What's the first term? Yep, 1/3 is my ratio. Oh, let's be careful here, folks, okay? I told you it's easy and it's easy, but there is something you do have to think about. We can't just throw caution to the wind. Look at the next one. What are you multiplying by every time? Multiplying by 2. Just think about if you add them up. Like, because the next one will be, what, 24, then 48, then 96, then 192. So, right? I mean, those are the numbers we'd be adding up, right? You think those are going to, like, hone in or converge to a certain number? Would you agree that sum just continually gets bigger? But watch what happens if we try the formula. Sum equals first term divided by 1 minus r. What's r? 2. Is there any way that that adds to negative 3? No. No. This works as long as the absolute value of r is less than 1. If absolute value of r is greater than or equal to 1, then the sum is equal to positive or negative infinity in most situations. So as we examine letter D, what was the ratio again? 2. Is that bigger than 1? Yeah, so it's not going to go to a number. It's either going to go to positive infinity or negative infinity. As you add these up, what would you say? Positive infinity. Yep. I sure can. You're welcome. Okay, folks, I kept to my promise. I have a worksheet for you, no packet, front and back, your second to the last assignment of the year. Last assignment will be next week, Wednesday, and that'll be it.